And there we go. Hello, welcome to the Geological Society of the Oregon Country, our monthly meetup for people who are either avid geologists or beginners or longtime professional geologists. This is the place for you to drop in and hear some conversation about geology. So for some of you, this is maybe the first time you've come to a Geological Society event. We call ourselves GSOCers. And some of you may have not ever taken a geology class or took one in college and haven't done it through your career and now are returning it. Some of you are professionals. We try to include everyone in that conversation. And the Geological Society of the Oregon Country is the oldest collaboration of amateurs and professionals in the Pacific Northwest. We have, or did have, monthly lectures. We still have monthly lectures and field trips that we would be doing at this time of year normally. But of course, that's all in suspension because of COVID. And instead, we're doing these meetups online, and we'll probably continue to do that because this format works out pretty well. This can be just your first step back into something related to geology. You know, we have some people who are interested in gems and minerals, and we can help you connect with groups that are allied with us who do that kind of work. We have some folks who are interested more in fossils. And so we have some people who are more doing that kind of thing, people who are interested in the plate tectonic story and other aspects of loving nature, birding, and so forth. So we welcome all kinds, all lovers of nature and lovers of science. And we're just hoping, we're glad that you're welcome with us here to be part of the conversation. So the way we handle it is we're going to do some announcements up first about Geological Society events. There aren't too many this year, but we have a good one coming up. And then I hope we're going to have Dr. Scott Burns. Is he with us yet? Don't see him yet, so hopefully he'll be with us. And then we have Andrew Dunning and his wonderful geological news. And we will wrap up with show and tell for those of you who've contributed rocks. Those appear in the Meetup event page. And we'll be sharing the screen and looking at those rocks and just having the conversation, because one of the things that's so delightful about being in geology, in Oregon especially, because you have access to professionals like Clark here and Dr. Burns and Sheila Elfson, our current president, is you can have these conversations with actual scientists and see the process that they go through when they encounter a rock that they have no idea, but the thinking process, and we are all part of that. So I find that really fun. And we've got at least maybe half a dozen rocks we can look at today. And then we will finish at 1:30. But I won't kick everyone out. I'm going to leave the room open if you want to hang out and chat a little bit. If you have questions, if you have something, you know, we say something like paleomagnetism and you don't know what that is, or feldspar and you don't know what that is, or rock and mineral and you're not sure what the difference is, put it in the chat. Carol Miles is going to be looking at those questions. And Carol, you have my permission to just interrupt at a moment and say, someone wants to know what basalt is, and we'll have that conversation, because sometimes we can kind of get off into the stratosphere or upper mantle, or I don't know, whatever we get. So no sign of Scott yet, doesn't look like. So I will jump into announcements. The next Geological Society of the Oregon, what are we? GSOC. The next lecture is October 9th. Now, normally those lectures are at Portland State and Kramer Hall 53, the big lecture hall where we have been for 47 years, once a month. Now they're online on Zoom, and our next one will be October 9th. It will be Friday at 7:30, right, Sheila?
Yes.
Yes. And our speaker will be Dr. Ashley Streig, who is a professor in geology at Portland State. She's going to be talking. Now, don't be frightened. This is the title. She's asked me to read the entire title. Paleoseismic evidence for Holocene surface rupturing earthquakes on the Gales Creek Fault, Northwest Oregon, and new insights into paleoseismic age models, detrital charcoal inbuilt ages. So there are 2 points there that make this super interesting. One of which is that Ashley is a rising star in the Portland State Geology Department, and we're very fortunate to get her. But the Gales Creek Fault is part of this parallel faulting system that is part of the whole Portland Basin and Tualatin Basin. And not that I want you to worry about this, But if we were to have an earthquake from one of those faults, and they're out at Mount Hood too, I think Clark can talk a little bit about that, it would be a terrible thing. It would be like a magnitude 7 or something fault earthquake. So don't worry about that. We have enough to worry about right now, but it makes it interesting. And it's part of the tectonic history of the Portland Basin and the Tualatin Basin for those of us here in Washington, Clackamas, and Multnomah County. The other thing is that she's developing a method using the charcoal that you find when you trench open a fault. She's using that as a method for determining earthquake ages. So I know that was a lot of technical language, but in very fundamental ways, this is an important lecture, and we're fortunate to have Ashley. Log in, you can, Sheila, what's the story about how people get to our lectures? Do they have to be members now to attend the lecture at the time it's being given? What do we decide?
I'm still a little unclear on that.
Okay.
So, because you guys do the technical aspect of GSOC, so.
I think what we're requiring at this point, since we have limited Zoom attendance, is that only members can log in when the lecture is happening and be part of the comment process, okay? We always then put the lectures on our website gsoc.org, so that it's open to the general public, because that's always been our practice, is having our lectures open to the general public.
Yeah, our lectures have always been open, and field trips require that you're a member or know somebody that's a member, have a friend.
Exactly.
And membership is not very expensive, $25 a year.
So,
it's, you know, not too bad.
So again, for the next lecture on October 9th, you have to be a member to attend at the moment, but it will be on the website after. So if you're after this meetup, you're still not sure, do I want to be part of this group? Do I want to pay $30 for an annual membership? You can still look at the website later, gsoc.org, and watch the lecture and get an idea from that. Any other announcements anyone has? Any sign of Scott? Okay.
Clark, it's raising his hand.
I have Degami just has published 2 new databases. One that I'm a co-author on, it's mine. It's there's a new mineral database out. It's called Milo 3. And Aaron, you might be interested in it. It doesn't have all your sites in it, but it's a little bit better. It has LiDAR. It is a capture of all the mine features that are present on LiDAR, particularly on the western half of the Cascades. And then OGD7, which is the Oregon Geologic Data Compilation 7, is a new database. It's updated. It is a geospatial thing, so that's a little bit troublesome. But if you know how to use that, it is an update, and it is much better than the previous version. So
when you say a geospatial thing that's a little bit troublesome,
geospatial thing, it's a GIS. And,
it's GIS.
I have a hard
So you have to have
system, and
so unless it's not something you can just open up in Google Maps, it's something you have to have ArcGIS or the open source QGIS to look at.
It was a curse of my last 20 years. But yeah,
hey, we could really use someone who's got their own version of QGIS or GIS who wants to help us with that kind of data. Clark, you have access to that, don't you?
I have access to all that.
Okay.
And Milo, I should add, is a new web map, so you can see that map there.
Clark, could you maybe do a demo for us at some point at maybe the next meetup to kind of show what the value of that is to those of us who are amateurs and are just curious sometimes what the geologic map looks like?
Be happy to.
Okay. See how I get him to commit when I ask him in front of 40
That's a
other
great
people.
idea. I like that.
But actually, when we ask, go ahead.
I learned too, when you talk in a meeting, you always volunteer yourself as well. So.
One of the questions we're always getting is, I found this rock over in blah, blah, blah. What do you think it is? And one of the first things I do when I get a question like that is I go to the online geological map of Oregon and I drill down to that location, and I try to get an idea just from that of what to see. And that's available to anyone. So sometimes those maps are a little hard to read, but they're open to the public and they're pretty easily accessible. Any other amounts?
Where do you find that map? Clark? Or,
All you need to do is in your browser is type in Dogami, Dogami, and you will get their homepage and you will be able to navigate through that. And if you go to the data publications section, it'll be pretty clear where you'll navigate after that.
Okay, great. Any other announcements before we get to the news? All right, Andrew.
I've
wait.
been texting Scott and no answer yet.
Okay.
Scott's
Well,
on. Hi, Scott.
Scott.
I'm here.
Yeah.
He's
Oh,
here.
yay.
All right.
Thank you, Patty.
Well, Andrew, if you
I had a hard time I had to go way back to a email from you 2 or 3 weeks ago, and I got the link.
Okay, good. Thank you for doing that. You know, we're making people log in through Meetup, and as you can imagine, we've got lots of reasons for doing that because of Meetup's connection to Zoom and all of these different little things. But I do appreciate people going to Meetup and logging in there because it makes us easier to control it and make sure that everyone shows up in the right place. So before I toss it to Andrew, Scott is here. Scott, do you need a moment, or do you want to tell us a little bit about what you've been doing recently with the AEG and maybe anything else?
3 things, and I'll keep it quick because it'll be fun to get into all of the other rock identifications, et cetera. Number 1, last week was the annual meeting of the AEG, Association of Environmental and Engineering Geologists. Supposed to have been here in Portland at that time, 15th to the 18th. Thank goodness it wasn't because of all the forest fires. All of our field trips would have been canceled, and it was virtual. And we set that up many months ago. It's going to be back here in 2023. And so if any of you are interested in the fall 2023 participating or helping, we are always looking for help. A very successful meeting, 530 people attended. Normally we get 450. So we had more people, especially from other countries. And it was very reasonable, $100 to sign up for the 3 days. I gave a talk on radon and the work that we've been doing in Oregon with radon. I also did a coast-to-coast terroir evening in sipping wine. And so I talked about the influence of geology and soils and climate on wine. And then I bounced all over the country, and people would say, "This is the wine I'm drinking." We talk about the terroir, and it was fun for an hour to do that. And there were 92 people on the call, so we got to talk a lot about those. I was very excited about Portland State students. Emily Smoot and Kara Kingan both had posters at the conference, and both won a scholarship, Lemke Awards, as we call it, $250. Kara Kingan also got 4th place for her poster. And then Melinda Muckenthaler, she helped Heather Clark, who was the meeting manager, and they are the ones who virtually had helped all of the talks be given virtually, and they did an absolutely great job. So that was good. A couple other Oregonians and potential talks for GSOC. Tim Blackwood talked about the work that they're doing in Oregon City and Newell Canyon, and that was very good. George Freitag, Mike Marshall, and Greg Martin gave a talk on the new Oregon State campus up in Bend, which is an old pumice mine. And how do you take an old pumice mine, dig it out, and then turn it into a place for a college campus? So those are some ideas coming up. Also, remember next year in the fall, October 10th through the 13th, is the annual meeting of the Geological Society of America, and it's going to be in Portland. And so there will, if we get the vaccine, and we will have a vaccine by that time, I'm sure that we will have a meeting at the convention center. It'll be 7,000 geologists, and you might be interested in taking part in that. The second thing that I'm spending a lot of time on right now is we are putting together a visitor center in Tualatin for the Ice Age floods. Back when Obama became president, the newest national park was the Ice Age Flood Geological Trail, following the Missoula floods over 16,000 miles in the Pacific Northwest. And They christened it, and instead of going to a mountain, going to a canyon, you follow a geological concept from Astoria up to Missoula, Montana. Idea 15 visitor centers. The other thing is they gave no money, and they finally this year gave one person to be in charge of that. But in Tualatin, we're going to be opening the very first visitor center. And we have been working all week on the video. We've hired a videographer. It is going to be called Tualatin, Crossroads of the Ice Age Floods. Floods came through Lake Oswego into the Tualatin Valley, and then came back through the Tonkin Scablands through Tualatin 40 times. And so that video and so we started shooting this week, drone shots, sites on the ground, interviews, and then we will be finishing up next week with most of the interviews and drone shots. The drone shots will be much better with the weather next week. It should probably be finished probably at Christmas time. And then we're going to be showing it at the library. That's our visitor center until we raise enough money for the visitor center. It's going to be dealing with the overall pictures of the Missoula floods in the Portland area, especially South Portland. Number 3, what were the animals that were there? The symbol of Tualatin is the mastodon, Tutu Tuala. And then lastly, we have huge collections of Ice Age flood mammals that have been collected by Mike Full and David Elligson down at Woodburn High School. Lastly, we're going to have a section on the Native Americans and the Calapuyas who occupied the Willamette Valley and the Tualatin Valley. They had legends of 2 big floods that completely filled the Willamette Valley. And then we're going to start with that and then talk about the Native Americans that occupied the Tualatin River. That was the Atfalati band, or translated Tualatin band of the Kalapuya. And then thirdly, dealing with forest fires and wine. And all of the wineries are very, very concerned about smoke tainting, because smoke gets onto the grapes and the smoke contains these phenols. And they get into the grapes and you can't wash it off. And so many of the wineries, we were 10 to 13 days with all of the smoke around us. How is that going to affect the crops? Some wineries, like that I work with, Elk Cove, they had no smoke out there in Gaston. And so they're going to be fine. But other ones that, for instance, on above Newburgh, huge amounts of smoke. White wines are probably going to be okay. You press the grapes, you aren't in contact with the grapes, and so the phenols will stay on the skins and not on the juice. But the reds, we're going to see. So that's a big question that is there. And and then I just absolutely love reading the literature and geology in the news. So I anytime I see something, I turn it over to Patty Hyatt. She turns it over to Andrew Dunning, one of our star students at Portland State. We just love Andrew. And then he translates it and brings you guys up to date on everything that is going on. And so I'm excited to be on the call today. We had a meeting this morning about the Ice Age flood video, and great ideas. And we're excited about that. So I will shut up and turn it back over to you, Paul. Thank you to you and Sheila and Patty for the invitation to come. And I've been a member for 28 years of this organization, so I love it.
Thank you, Scott. And I know when we meet in person in Kramer Hall, Scott will sometimes provide actual samples from his terroir expertise that people can drink in the office there. We'll have to postpone that for a happier day. But I have so much wine now. So I'm going to make sure that every GSOC meeting that we meet in Kramer Hall, that we will have lots of wine, and we explain the terroir of each one of the bottles. So we got lots of wine.
You always have a special standing invitation from us. You know that.
Yeah, you can come to board meetings too. I mean, and feel free to open one up. Scott, did you mention the GSA, the upcoming GSA conference, which is going to be virtual?
Yeah, the upcoming one it was supposed to be in Montreal. It is going to be virtual. That's this year, October of this year. But then next year, they're still planning face-to-face meeting in Portland, and I'm hoping that we will have a vaccine by that time, and that will be a reality.
It will actually be
And
here,
we
but
will plan on having a table like we did at the Cordilleran event. So we'll be trying to put that together.
so if you are interested in the GSA conference in October, it's Monday, the 26th through Friday, the 30th. I think it's $200 if you're a member. Again, for those of us who are amateurs, you know, it's kind of getting thrown into the deep water there, but with some of the technical papers, but boy, it's fascinating. And I think it's great, again, for those of us who are amateurs to kind of listen in on where the scientific conversation is. And the fact that it's virtual, Scott, I mean, to me, that's because I wasn't going to be able to attend until 2021, but I'll be able to you know, drop in and out. I don't think I'll be there every day for the whole 8 hours or whatever, but the virtual has a lot to be said for it as far as attending some of those conferences. Any other announcements?
Well, one
Before-
other question
Please,
is,
Sheila.
where will this interpretive center in Tualatin, where will it be? You said it's at the library now?
Yeah, right now the center is at the library. And in fact, if you've got a passport with the National Park Service, you get a stamp. We got the very first stamp of the Ice Age Flood National Geological Trail, and it has its own symbol. And it probably the problem is the library's closed right now too. But once it reopens, and we'll have it there probably for another 6 months or so. We're looking to raise funds to have another visitor center in one of the unoccupied storefronts in the Tualatin area. So that's our goal. That's our dream, our vision. We're just excited about this video that is out. We have an award-winning videographer that is putting it together, and I think it will be very good. And our dream is that all kids in either 6th, 7th, or 8th grade in all of South Portland will take a chance to come and visit the center when we have got that, and they will learn about the Missoula floods, not only the big picture, but then secondly in the local area, and then the animals. And one of the scenes that we have is Mike Full out on the South Yamhill River at latter part of the summer when the water is low, diving with scuba gear for fossils and looking them in the banks. And they just filmed that last week. They actually found a tooth of a mammoth, and 2 kids found it, and then they bring that into the collection. That's how they are done. And then we also have the same thing down in Woodburn. David Ellingson every year has a big dig, and they have thousands of people down there digging and then finding the fossils in the old bogs that are down there. So it will be an exciting thing, but I'm hoping that every kid will come to learn about the floods, learn about the animals, and learn about the Native Americans that was there. Where did the word Tualatin come from? Well, it was one of the bands of the Kalapuya. And so it's all getting kids out, and not only kids, but all of us learning about the natural environment that has been created here.
And I know you're working with Dr. David Lewis, who's associated with the Grand Ronde tribe. Are there artifacts that are present that have been discovered that will be in the museum, or will there be other interpretive materials?
Yes, and so we're working with the Grand Ronde tribe. They have their own museum. We're going to take some of their items that they have got. They always have duplicates and stuff, and those will be there too. So it's very important.
Sounds like a field trip for GSOC at some point. That'll be a nice one when we're able to take our field trips again. Sheila, do you have anything to say about field trips for 2021? People can be, so there's, what can we look forward to when the gates open up again?
Well, we have several field trips, and of course, most of them went on hold, and several of them are rescheduled for 2021. So, they're not all dead. We also have some good ideas of new ones that we're putting together. So we keep coming up with ideas. We've been kicking around some ideas at board meetings about new ones. So look forward to hanging in there with us. We're one thing, since when I was president in 2014, we became aware of the need to have a few more local field trips. So folks that are working and can't get away for an extended period of time can still have one that you can do within a day's drive of Portland. And so we're working on some of those as well. So we'll have some new offerings, and then some of the ones that were canceled will be rescheduled for 2021. So don't give up on us. We're going to get outside no matter what.
Don't give up. And just to mention a couple of the local field trips that we'll be restarting when we have a chance to. One of them is the Downtown Building Stone Tour. That is very popular. And we'll also be doing the Naked Geology Bike Tour, which is not actually, it just happens to be on the same day as the Naked Bike Ride. But
You wear clothes on this one.
you want to wear clothes on that one. And we will be doing tours of Mount Tabor in the Buttes, and I think the Johnson Creek Watershed Tour, and probably the Clackamas Watershed as soon as it's safe once again to be doing a tour in that area, where we can anticipate certainly some landslides after the fire damage and that. But the geology there remains. So one thing we can kind of comfort ourselves with in this time when people have had loss of property or even life is that the geology is there and it'll continue to be there. So that's something we have yet to look forward to. On that note, Andrew, I think we're ready to hear other geology news. If you'd like to jump in and maybe share your screen, I think we've made you co-host.
Sure will.
All right.
Let's see.
Andrew, tell us a little bit about yourself as you start.
All right. I am just starting my master's degree at Portland State underneath Ashley Strag, who will be giving a presentation next week. Was that?
Was it next week? October 9th.
Oh, October 9th. 2 weeks.
Friday in October.
How do numbers work? October 9th, it's a Friday, yeah. Did I give a good explanation of the significance of her work, Andrew?
Yes, absolutely.
Okay. I'm excited that it sounds like it's not just the question of these faults, but it's also the method that's being used to figure out the age of the faults.
Yes, using the carbon dating for buried charcoal it's been around for a while, but she has really sort of been pushing it to new levels and has been doing a lot of work developing this technique, especially on the San Andreas fault. Her paper that came out a few months ago, back in May, it was really interesting. I'm not going to go into it because it's very technical, but it was a very interesting sort of new technique and new methods.
Good, because
Really,
I think the
really
question
refined.
for us who live in the Portland and Tualatin basins is, when did those faults last activate? Has there been a big earthquake from those faults in the Holocene in the last 12,000 years or not? And I think that's the question that is the source of.
Well, the Gales Creek fault moved in 1993. We had the spring breakquake.
Oh, that's true.
Got a new high school. McMinnville got a new elementary school. There's quite a bit of damage. And they had to repair the bridge going over the Yamhill River on Highway 18. All of that was a fallout. 1993 spring. We called it the spring breakquake. How many were around for that? Anybody remember that? Okay, I lived in Yamhill, so I was right on the fault, or very close. 5:30 in the morning. It's significant of 5.6. So remember, a 7 is going to be 100 times greater than that. No.
Yeah. So I think one question is when the Portland Hills fault has moved last. So that's not something that we need to worry about today. Andrew, I've interrupted you, I think twice now. I'm going to shut up and let you get on with the news.
Oh, I don't mind. I got news here, everybody. Compared to other months that I've talked about in the last few months, this was a relatively quiet for world geological events. But I'm going to start with my favorite, which is earthquakes. Another quiet month for big earthquakes around the world. The biggest was a magnitude 6.9 on the Mid-Atlantic Ridge on a section of transform plate boundaries. This is a strike slip horizontally moving fault between the African plate and the South American plate. You can see there's a little cluster of them over here. I don't know if you can see my cursor.
I can. We're still seeing your screen in presenter view. I'm not sure if you want to keep it that way or if you want to make sure that there we go.
There we go. All right. These are all of the earthquakes that happened in this month. I believe there were a couple of smaller ones in the Indonesia coast, which I cleverly chopped out of this image here. But anyway, another quiet month for earthquakes. A cluster of magnitude 6 on the subduction zone off Chile. The largest was a 6.8, which is quite a large shaker, and it had 2 aftershocks over magnitude 6. That was right down here. And there was another one up here off northern Chile or southern Peru. I can't remember exactly which, that caused some landslides and some minor damage from there. I have not seen any reports of casualties, so that's good. And the subduction zone continues to do what it does best. There is an unusual 3.1 magnitude in New Jersey. So we do get earthquakes in sort of Virginia, South Carolina, and up in the New York area quite frequently, but the geologists over there, I believe it was the New Jersey Geologic Survey, or whatever their official title is, they said in a press release that this was a very unusual place to have an earthquake. It was really small. It wasn't quite big enough to get a good focal mechanism on, so I couldn't find a good way to analyze it without actually taking the data and manipulating it and putting it into the program and going through a lot of work, but I didn't want to do that. So it's a weird earthquake. It was really shallow. It was only 5 kilometers deep, which up here in the northwest or elsewhere, even in the northeast, I would think might be related to glacial rebound, but this is way far south of the maximum extent of glaciation. So it was very curious. And there was this great quote here from one of the geologists over there. There's a consistent pattern in the eastern United States that the earthquakes are responding to a squeezing force in the northeast to southwest direction. There isn't one big fault line, but the rocks around the New York City area are hundreds of millions of years old, and they've had a rough life. So all sorts of fracturing and stuff going on over there.
So Andrew, last month we talked about a weird earthquake in, what was it, North Carolina?
Yeah, that one was interesting.
And what did we decide? I mean, to the extent that we were able to decide what might have caused that, is that anything similar to this, or is it a similar mystery?
The North Carolina one, it turns out, is not that unusual. They get earthquakes in that area a few times a century. This particular spot in New Jersey, I did not see anything near it in the last 30 years of comparable size, apart from a larger one in Delaware. But it seems like, based on what I was able to find and read when I was just preparing for this, is that an earthquake of the size of a 3.1, which is, you know, chump change over on here on the West Coast, but a nice little shake for people in New Jersey. It's just kind of weird. These things happen. That's what old rocks do. Sometimes they shake. There was a fun 3.9 in England. What was that?
Oh, I have a question. So you hear about the earthquakes associated with fracking, which are usually not very intense. I don't know if there's any fracking going on in that area. Is that a possibility?
There is not any active oil and gas exploration in the Piedmont coastal plain, New Jersey region that I am aware of. I almost skipped over this 3.9 in England, which is, they don't get a lot of those in England. There is a widely felt magnitude 4.5 in El Monte, California. You can see it right here. This is in the Los Angeles basin. This is the Inland Empire, places that I'm glad I don't live anymore for a variety of reasons. But this little tiny one is a reverse fault, a compressive earthquake resulting from north-south San Andreas forces. You can see the San Andreas fault up here. And this is the southern end of the northern end of the Whittier fault zone and the southern end of this fault here, which the name is blanking on me right now. But as you can see, there's a couple other earthquakes on here. This is a very, very seismically active region, and earthquakes of this size are quite common. And I'm going to move smoothly along to volcanoes, with 42 volcanoes with ongoing or new eruptions in September. Pavlov in the Aleutian Islands was raised to an advisory state due to ongoing seismic swarms, but it was overall a very quiet month for volcanoes. So now on to some new, interesting, and novel stuff. There was a new set of dinosaur tracks found in the Grand Canyon, which has been dated at 313 million years old. Look at these things, they're beautiful. There was a rock fall in the canyon, which exposed this new face of this boulder, which this boulder apparently had been seen before, but the rock fall sort of moved it in a new way. So now we can see this face with these lovely reptile tracks on. They've been called the oldest vertebrate tracks in the Grand Canyon area and among the oldest reptile-like tracks in the world. I say reptile-like, but they said cold-blooded egg-laying creatures, which sounds like a reptile to me, but I'm not a biologist, so I'm not going to make that distinction. There was a new paper from Dan O'Hara at the University of Oregon that combined a variety of methods to study the volcanoes of the Cascades. They were specifically looking at the volume of magma erupted and the timing of what volumes of magma were erupted. And they found that distributed volcanic sources, so this is cinder cones, all of these red dots are different vents and the white dots are the big volcanoes that we know. Distributed volcanic sources like cinder cones, in addition to the big stratovolcanoes, have been producing the largest volume of volcanic material over the last 2.5 million years. A flesh sample of an extinct woolly rhinoceros was found in a mummified dog puppy from Siberia. And it was dated to about the time these woolly rhinoceroses went extinct. I believe it was about 14,000 years ago. So we get, this sample has been well enough preserved in the stomach of this mummified puppy that we've been able to do genetic analysis on it. So that is coming in the near future as well. And in less interesting news, glacier ice tongue in Antarctica has been melting at 7 to 16 meters per day, which is a new high melting level that we have not seen before on this particular glacier in Antarctica. And that is largely due to warming ocean temperatures and warming atmosphere temperatures in the Antarctic. Hematite has been found on the moon. And the big question for that is, where did the oxygen come from? Hematite, of course, is iron oxide. The rocks on the moon are very rich in iron. A lot of them are basalts or basalt-like. So they're very rich in iron and magnesium and some other things like that. But the moon doesn't have an atmosphere. It does not have a lot of liquid water. So where did all of this oxygen comes from? So there is water ice that has been found on the moon, but it primarily stays frozen, except in the poles where the most of this hematite has been found on the poles of the moon. But one of the leading hypotheses they came up for this discovery is solar wind blasting oxygen out of Earth's upper atmosphere, and then this oxygen floats over to the moon and causes oxidation for these hematites that you find on the poles. So that's very interesting. I'm looking forward to more news from that.
Okay, Andrew, I want to stop you for a second. And if you could go back to the previous slide, because exactly, I was curious. And by the way, if you have questions like what is hematite, what is a transform fault, put them in the chat. And that way we can kind of, handle them as they come up. There were a couple questions here I had about the Cascades volcano information. Does that really change our picture of what's been going on with the Cascades?
It doesn't change our understanding, but what it does is really clarify and improve it. They really nailed down the timing on a lot of these. It's really complicated. I don't want to get into it too deep because I don't know enough about it to get into it deep. But the volumes that have been erupting from the Cascades has been changing a lot in the last really 10 million years. But the last 2.5 million years really covers most of the recent and well-preserved volcanic rocks in the Cascades. And one thing they identified was the amount, the huge amount of material that came from these distributed sources, all of these red dots, compared to the large volcanic edifices. Yeah,
I mean, that was the impression that I got. There was a lot more than, or maybe many volcanoes than they had anticipated, but I don't know. And maybe Scott could chime in on whether that fundamentally changes or just confirms our understanding of Cascade volcanism.
In my mind, that really just confirms and brings into better focus what we already figured.
So it's pretty cool.
The really exciting thing about this is that they got good estimates for volumes that we didn't have before, because they discovered a lot of things like dikes, and because they were using magnetic and gravity data and some other things, they found things that are buried that are of more recent age.
Great, thank you. Okay.
Yeah,
so the next thing looks pretty interesting. So I wanted to stop you before you got to the Carney and Pluvial episode. So tell us about that.
Hold on, Patty had a question about the hematite on the moon and wondering if there's a hematite water connection.
Yes, hematite is found you get iron oxide mostly in the presence of water. Like if you stick a cast iron nail into a bucket of water, it's going to start to rust, and all that rust is primarily hematite and some other stuff.
And this is coming from water. Water on the moon is coming from the barrage of protons that are hitting the moon, or how does that work? Where's the water come from?
Yes. So there is water ice on the moon, and some of that, especially in the polar regions, does melt.
Okay.
Sort of seasonally, depending on solar cycles. But a lot of this oxygen, this is gaseous oxygen. Most of this hematite was found on the side of the moon that faces the Earth. And so they thought that when the moon is sort of in the shadow of the Earth, so when we get a full moon phase that we see, solar wind is blasting the Earth and its magnetosphere, and it's blowing oxygen from our upper atmosphere into the moon.
Okay. All right. Thanks.
And how they figured that out, it's the methods section is extensive in that paper. So interesting things in historical geology, we identified a new mass extinction. The Carnian pluvial episode triggered the age of the dinosaurs about 233 million years ago. It was caused by flood basalts, now part of the British Columbia, called Wrangellia, and that's what we call an accreted terrain. Much like Silesia here in Oregon, this was once an offshore landmass that got squished and shoved and peeled off onto North America as the Kola plate subducted.
So what is pluvial?
See, I think of the word pluvial as being sort of an ice age temporary lake. I don't know how it applies to this age.
I mean, it comes from rain, right?
That's what I think. I don't exactly know where this name comes from in relation to this mass extinction event.
How did they identify what was the data that?
So the interesting thing about this is that a die-off had already been recognized here, but it was thought to be local, sort of a North American thing 230 million years ago. But this researcher started collaborating with other researchers around the world and found that there was a significant change in vertebrate species and in the ocean as well that corresponded to a more global die-off at this point. Now, dinosaurs had already been around for millions of years before this event, but this pluvial episode really helped open the door for the dinosaurs to become the dominant life form on the planet for the next, what is that, 190 million years, 200 million years almost?
Subtract 65 from 233, I guess.
However,
I know usually they're kind of hesitant about asserting that there's a direct cause and effect link between flood basalts and extinctions, and that's kind of controversial in the case of the ultimate dinosaur extinction. What's the basis for saying, is it just the overlap of the timing of the flood basalts, and how are they getting those dates?
Precisely. That's exactly it. So it turns out it's a very large flood basalt province. It stretches really from parts of Alaska all the way clear through British Columbia. It's quite an extensive piece of accreted rock. In this paper, I really should have included the names and the links to some of these. I'll have to do that next time.
We can work on that. Yeah.
Yes. And they had a map of all the rocks from this Wrangellia flood basalt episode, and it's a lot of rock. Clearly a lot of material got erupted and basalted, extruded during this time.
So a lot of samples, and do you know how they're getting age dates from those samples?
I didn't read all of that methodology.
I'm guessing that's typically sort of, argon, or krypton, or whatever.
Yeah,
this is not my field, so this is more your terrain, as it were.
There's too many different radiometric datings for me to keep track of them.
Okay, but that's probably how they got those dates, and then they correlated those with, someone's missing from the fossil record at 233 million years ago, and that's where the die-off was. Okay.
Exactly.
Fascinating.
And there was an earthquake swarm in Yellowstone.
Oh.
91 earthquakes in 24 hours, and this is Yellowstone is obviously a large volcano that last erupted about 660,000 years ago, if I'm pulling that number off the top of my head correctly. But this is very normal. You get a few of these every year, lots of these every year sometimes. And this one is average to small sized for Yellowstone. This happened in 24 hours on September 11th. Really is normal background activity.
So given-
Steamboat Geyser had quite a few eruptions during this last month as well.
Given that it's 2020, I'm glad you're giving us that reassurance. This is just normal.
Yeah, increasing activity at Steamboat Geyser over the last few years is very interesting. Steamboat Geyser, if you're not aware, is the largest geyser in the world.
Didn't know that.
I believe it has eruption heights. It can have eruption heights in excess of 400 feet, which is colossal. I could be way off on that number. I'm going on memory here.
So Andrew, how often do those swarms occur? In
These
Yellowstone?
earthquake swarms, like this one, will happen a few times a year, maybe as often as once a month, but I think usually a little less often than that. Sometimes they'll last a few hours, a few days. Once in a while, you get one that'll last about a month.
And this is considered a small to medium-sized swarm?
From what I've read, yeah.
Wow.
You get other ones that'll have 2,000 earthquakes in as many hours. And these are really due to fluids and gases underground. There are different methods that have been coming up in recent years to figure out exactly what's causing earthquake swarms. And even though Yellowstone is one of the best monitored and instrumented volcanoes in the world, none of them have really been deployed out here as far as I know. Like you could have had a gravimeter, a gravity meter plopped on top of here, and you can actually measure the density of whatever is changing beneath that gravimeter to find out what's moving below you. Like on South Sister, there was an area to the south that was uplifting. It uplifted about 1 meter over the course of around 10 years, I believe. And they did gravity measurements from satellite. They did not, as far as I know, get a gravimeter out there.
Wow.
And they determined it was indeed a mass of molten rock that had intruded about 5 kilometers deep. So these little earthquake swarms do happen. They're normal for a volcano, especially a volcano the size of Yellowstone. We even get these underneath Mount Hood sometimes. Not quite as many earthquakes or as large, but you know, volcanoes or earthquake swarms are interesting and quite common. Looks like that's the end of my novelties slides. There was a lot of interesting papers that came out this month, and I did not have time to dive into all of them deeply. Thank you, Patty, and Paul, for sending me as many great articles as you do.
Sure. I just have a Google, I have a few Google alerts set to bring some articles into me, anything that's related to the Columbia River basalts or local volcanics. So we just send them your way. Clark has a comment. Oh, I see. Are there any questions about the news of the month?
Yeah, this is Bill. Can you hear me, Paul?
Yes, very well.
So there's a rather large eruption down in Ecuador, down just south of Cotopaxi, a place called Sangay erupted, I think on the 20th. So that's pretty good size eruption.
And what kind of geology is resulting that?
Well, that's right in the Andes. It's one of
in
those
the Andes.
Andean
So
volcano.
it's a subduction. It's similar to our
Yes.
Cascaden volcanoes. Okay.
Yes.
I didn't see that one. What was the name again?
Sangay.
Thank you.
And that earthquake swarm was in an unusual place for Yellowstone. Typically, the swarms have been occurring up by Norris Basin. That's where Steamboat is. But down where you showed it, Andrew, that's a fairly unusual position for a swarm.
So, Bill, are you worried?
No, because
Okay.
everything
That's
will
good.
blow. We have the westerlies, so it'll blow everything west,
Okay.
or to the east rather.
Sorry, I shouldn't be stirring up trouble.
Oh, nice little pyroclastic flow coming off that Sangay eruption.
Can you share it with us, Andrew?
I'm looking at it on my phone. No, I can't. Oh, I can pull it up and let's take a look. volcanodiscovery.com.
Okay, I can show it.
Oh, you got it?
It's a pretty amazing video, yeah.
Yeah, do you want me to share?
Show it, show it.
Okay, let's see if I can.
Ooh.
Wow.
Okay, wait, it went away. I have to move my, sorry.
Now, a few years ago, Sheila and I went to OMSI to see the Vesuvius exhibit. And she was quick to point out when she saw just the shape of the volcano that they'd made a mistake. So Sheila, looking at this volcano, what can you tell us about the composition from its shape?
Well, it is a stratocone volcano, and that's where we get the word andesite. See, the Cascades are made out of a rock called andesite, and andesite is named after the rock that's characteristic of the Andes. And so this is very similar to what we would have here in the Pacific Northwest. And I muted it.
Make it go.
Paused it, but I can go ahead and share
Yeah,
it.
go ahead.
Then let's go full screen. Okay. Here we go.
Let's keep it under 20 seconds so we don't get a copyright hit from Google. But that shows us, I think.
Okay,
gives-
now if we go back to, I just paused this for, you asked about the shape of the volcano.
Yeah, yeah.
Stratocone volcanoes are the kind of volcano that everybody thinks of normally as a volcano, a cone. But the cone is formed by two different things. It's formed by eruptions of loose material, tephra. So think of Rice Krispies falling in a pile. And then a subsequent eruption of lava kind of cooling and kind of gluing it all together. And so they're called stratocones or composite cones because they're made of two different separate processes combined together. So loose material, lava, loose material, lava. And that's, and here you can nicely see the lava flowing over the surface. What you didn't see was the tephra, which would have looked like a big cloud. And this is how it builds up over time. It builds up this cone shape that you think of as a volcano.
What's that stream of orange? Is that
That's probably just something to do with the filming,
Oh, okay.
although there's so much electric activity going on that there will be thunder sometimes and lightning strikes during an eruption as well.
and the cloud that's going straight up, is that ash or water vapor?
That's ash and probably tephra. Yeah.
Okay. So when that falls down, it's going to make.
When that falls down, then we call that a pyroclastic flow. Okay, so right now there's enough gas moving it, charging it, and shooting it up into the air. But when it becomes more dense than the gas can shoot up into the air, it'll collapse in on itself and come rolling down the sides of the mountain at about 150 miles an hour and incinerates everything in its path.
Mm-hmm.
So the pyroclastic flows are the most dangerous aspect of a volcanic eruption.
Okay.
Okay.
Great, thank you.
They're showing you, I think they're showing you the Lahar damage here.
Mm-hmm.
Well, the ash fall, but then when that ash mixes with melted ice, where do you melt ice? Well, there's ice, there's glaciers on these volcanoes. So as soon as they melt, then that ash mixes with the water, and these send a slurry of, they were sometimes called mud flows, but we use the Indonesian term lahar to talk about them. And a lot of the Pacific Northwest is lahar material.
With an andesite eruption like that, is that comparable to what an eruption at Mount Hood might be like?
Yes. Troutdale.
Troutdale. Okay.
The Troutdale Bridge, and go to Glen Auto Park and Troutdale, and you'll see Lahar's material. Go to Oxbow Park and look at the trees that were buried in Lahar's. And I don't know if they're still, they were uncovered by normal river erosion about 10 years ago. I don't know what the status is now. I'd like to, anybody want to go there with me?
I do. In fact, I might be going there this week.
I did it about 10 years ago, and I'd like to see it more recently and see if they're still there. But stumps that are about 30 feet high were buried. These trees died when they were buried in lahar material to about 30 feet. So this is all the Sandy River doing this. This is why Lewis and Clark named it the Sandy River. It was still discharging ash when they came through in 1803, 1804. It was still discharging ash from the 1798 eruption of Mount Hood. Yeah, we're in the shadow of volcanoes here. Another thing that makes the Pacific Northwest so beautiful and potentially dangerous.
Yeah.
Okay, I'm going to stop sharing here.
Okay, thank you. One last earthquake related topic for those who live in Portland who may have been aware of the unreinforced masonry or URM issue that arose several years ago now when the city passed a placarding ordinance that would have threatened the many commercial property owners, music venues, and the Black churches in North and Northeast Portland, and provoked a response from those constituencies that stopped the URM placarding initiative in its tracks in federal court, eventually got rid of the list entirely. And then just this week, I got an email, or just yesterday, got an email from Jana Papathemiou, who some of you may remember from Portland Bureau of Emergency Management, who was on our panel, was it last November? Was it just last November? Talking about Cascadia Preparedness. And now that committee and that initiative has been disbanded by the city. So that's good news if you're a commercial property owner, or if you go to church in North Portland, or if you are in a music venue that you are fond of. It raises the question going forward of how we're going to continue to be prepared for a Cascadia earthquake in our urban centers, or any center where you've got these old unreinforced masonry buildings or whatever, the soft concrete buildings. I'm not using the right term there, but that issue is going to continue. And I think, and hopefully we'll get John or some other folks from Portland Bureau of Emergency Management or the neighborhood emergency teams back, because after this COVID experience, I think a lot of us have been thinking a lot about disaster preparedness and how that affects different members of the community. We have personal experience now. I think it makes it a lot more real what we would be facing if we have the 30% chance that we'll have a Cascadia quake in the next 50 years is something that it's a little more tangible now, what it would mean to be without water or to be responding to a smoke emergency and those sorts of things. So stay tuned for that. I see someone else has pointed out there's a 6.1 quake south of Africa along a transform fault on the Middle Atlantic Ridge. iPad him?
Yes.
Okay.
Yes, you do.
Want to talk about that?
Well, I did it through the USGS site, and I get sent worldwide anything that's over 6 point. And I pulled that up just now. I'm a new member here, or a new participant.
Thank you.
And I get these feeds, and it's from the USGS. And it looked like it was on or near a transform fault on the Mid-Atlantic Ridge. And that's about all I know. You can go to the site and pull up regional maps and then go to tectonic plate boundaries. It's a good way to do that.
Okay, and so you can get a constant stream of earthquakes from around the world and
yes,
be notified. That's great.
I can send you that link if you want later.
Yeah, please put it in the chat, and I'm sure that there are people who would like to follow up on that. Anyone want to? We heard it a couple of times. What's a transform fault?
Well, the Earth is round, as I understand.
You won't get any argument from anyone here, I hope.
And when a Mid-Atlantic Ridge starts to split, it can't split in a straight line. So as it opens up, it creates a transform fault, which is essentially trying to accommodate that curvature, as I understand it.
That's a good way. That's a good explanation.
Uh,
Sheila's doing it with her hands. So let's watch Sheila's hands.
Exactly.
So plates can do this. They can pull apart.
Right.
They can go together. That's subduction.
Right.
Or they can move side by side. Only
Right.
different ways.
Okay.
This is not the kind that causes a tsunami.
Ah,
No.
that's good to know. All right. Well, we're at the 1 o'clock hour, so we're going to shift into our show and tell. And again, to do show and tell, what you want to do is drop a photo and maybe a description into on the Meetup page. It helps if you tell us where you found it, because that's going to be the first question we ask usually. Also, if you can give us an idea of the size so we can have a rough idea, and also what it means to you personally, you know, something you found in your grandmother's yard, something you've had with you in your house for tens of years, or just something you found yesterday. Let us know. Is Larry here? Someone named, I don't see a Larry in the list. So I don't know if we want to go to his. Let's see. I'm going to share my screen though. All right, people see that? So Larry's question, which I'll ask since he's not here, is this worth cutting open? He wonders, is it an agate? So any of our experts want to weigh in? By the way, do anyone on the committee, can you go to the Meetup page? Because I can no longer see the description. I made it large screen on my screen, and now I'm stuck because everyone's looking at my screen. So maybe Carol or Patty or Mike Clark or Andrew, what is the question that is asked in accompanying this photo?
He says, worth cutting open? Quartzite?
Does he tell us? Does he tell us where it's from?
It doesn't look like it.
I think he thinks it might be an agate. I thought it might be a quartzite. And you know, for those of you who may not even know what exactly you've heard of agates, but what's a quartzite? Sheila, okay, it's not a quartzite. Sheila says, so why is it not this thing that some people don't even know what it is yet? So explain.
Well, agate is just another form of let me think about this. Agate is a rockhound term, so agate is cryptocrystalline quartz, which just means that the quartz has been dissolved in water, and then the crystals are so small you can't see them. However, look in the center there, and you see a little bit of crystals forming. So I think that this was a bug.
What's a bug?
An empty space in there.
Okay, there was a hole,
kind of like a geode forming. Yeah, and agate is banded. I can't remember if it's calcite though. No, it's not.
No, it's of course.
Yeah, I don't know the rockhound terms, but it is cryptocrystalline quartz. A geologist would call, so this is not quartzite. Quartzite is sandstone that's been squeezed and a metamorphic. This is probably the result of precipitating underwater. Okay, but it looks like it with those holes in the center and those big crystals.
You're going to have to explain precipitating underwater because
turning into a solid from a liquid.
Okay.
Precipitation. Not rain and snow.
Okay.
Precipitate means to fall. So when rocks are forming and underneath the ocean, and you get a solid from a liquid, like salt crystals forming as precipitation.
So what you're pointing out, and I didn't notice this, is this sort of little space here that are these sort of crystalline edges? Is that what you're seeing?
That would indicate that the whole thing at one point had a hollow space and was forming crystals in the center, like a geode or even a thunder egg, similar to the Yeah.
Very observant. I didn't notice that at all. It looks like
That's
it's had
the
a
first
rough
thing I
life.
noticed. And if I had a hand lens, I'd look at that and tell you if it was quartzite, but I'm almost sure it isn't.
Okay.
I'd really have to look at it with a hand lens.
So really to answer this, we'd want to look at it with a hand lens. We'd probably want to break it open if it wasn't his favorite rock. And so maybe it is. Larry, if you're out there, in answer to your question, maybe it is worth breaking open.
No, well, I would saw it. I would.
You would saw it. Okay.
Yeah, I saw it with a diamond bit saw. And that's how you would get, if it's agate, it's going to be banding and there's going to be pretty colors and you can polish it. And that's,
Do we have any gem and mineral people here who would find this? I'm not volunteering Larry's rock because it's not in my possession, but does this look like something appealing that you'd want to saw into?
depends on who you are.
I guess so. All right.
I don't think it's yeah.
All right,
It's always worth a try.
Okay, is Jeff here? I don't.
Oh, actually, no, that's just the person who took the photo.
Oh, it's the person who took the photo. It's Aaron. Well, Aaron, you're here. Wonderful. Now, Aaron, these were taken by Jeff Scoville. Tell us.
Yeah, actually, he's a professional photographer, and this one was put in a magazine last year. So
okay.
Yeah, my interest was I've been collecting rocks and minerals since I was old enough to walk. But people usually think of Oregon as just having petrified wood and thunder eggs and cryptocrystalline quartz, and so it's been one of my goals to find some of the other interesting things that Oregon has, and this is one of them. You
found this?
Yeah, read about it in a geologist master's thesis.
I see.
Southeast side of the Wallowas. There's some skarns along the contact of the Clear Creek stock, which is a little bit north of Cornucopia. This one actually came out of a little prospect pit. In that area, pretty much anything which had any quartz showing in it, it's got a prospect pit on it by miners looking for gold, but it's obviously not what they found here.
Okay, well, explain this to me, because the rocks I look at are usually not quite as interesting as this one. I don't see crystals a lot of times. So explain this to me like a 5-year-old. What am I looking at?
Well, these are dodecahedral garnet crystals. And garnet's pretty common, but not that common, really well-formed crystals like this. And this is also pretty unusual for Oregon. Where it's found is just an outcrop of massive garnet, which had little quartz seams in it. And you break up the boulders and some of the quartz pops out and exposes little things like this. This one is unusually nice for that particular location.
Yeah. How big are they, those dodecahedrans?
This specimen height, total height is about 4.2 centimeters, so about 1.5 inches.
Okay. Okay. So we do see garnets in our downtown tour in some of the nices there. And my understanding about garnets is that they can pop out of metamorphic rocks under high pressure. I don't know much more about them.
Yeah, this one's a contact metamorphic rather than regional,
So
like the garnet.
Explain what that means. Explain that. I know what that means, but explain what contact metamorphism is.
Oh, contact metamorphic. So it's essentially where an intrusion came in contact with limestone, like a molten granite or something like that, or
it got heated up. Yeah.
Yep. And usually there's some acidic fluids associated with the granites, and so that reacts with the limestone, and then there's a lot of fluid mixing and interesting things crystallize out. Sometimes there's economic mineral deposits, like in California, a lot of the skarns down the Owens Valley have tungsten, copper associated with them.
That's such an exciting process. Okay. So there's like a basalt intrusion, there's magma, it heats up the fluids, it sends all kinds of minerals into the surrounding rock, which in this case were calcite, they were limestones. Is that what?
Yep.
Okay. Wow. Tell me again, give me an idea of where in Oregon this is, because I didn't somehow get a picture of that.
Oh, southeast side of the Wallowas. It's outside the wilderness area, fortunately. So it's a little bit east of or west of Fish Lake, where you have to go through halfway and drive up to Fish Lake, which is a really, really beautiful spot to camp. Or you can get up to the area hiking up from Cornucopia to the north.
So the Wallowas are old. They're one of those accreted terrains typically. Limestone, you got to have a tropical sea for limestone, don't you? So the story of how you get limestone in the Wallowas is not a simple one, but I don't know. Does anyone else? I didn't know that there was limestone in that part of the world.
There's a lot
Yeah,
of
There's a lot of limestone, says Andrew. Go ahead.
Limestone.
On our trip last year, we saw a lot of the Martin Bridge Formation, which is limestone. And I just got, seeing this rock of yours, I got this weird rock last year in the stream bed. And I thought it has some crystals sticking in it, and it's kind of interesting. So it might be kind of similar mineral, but it's not as good a specimen as that.
So Carol, if I had read Carol's article on that Wallowa trip a little more carefully, I might have remembered that there were limestones that were viewed. Carol, I made you co-host if you want to show us the rock.
Yeah, or you could just use the speaker view if the other screen share goes away.
I can make that happen.
Yeah, just put it on speaker view so you can see.
Now we're seeing Carol and all of her.
Yeah, I will continue to talk. Let me get my face out of there and see if the camera.
So are those garnets?
Well, I don't know. See, there's these crystals that are kind of sticking out, and there's one on the side. Let me find it, where you can see the hexagonal.
Yeah.
Yeah. Is that in focus?
Ish. Yeah, sort of.
Too good.
Yeah, well, we'll have to bring this to a meeting, but I'd like Aaron to take a look at it and see what he has to say about it. It was just a weird, interesting rock with crystals, and then you can see where crystals have eroded out of it. So the imprints. So I'd be happy to donate it for a teaching rock or whatever. It was sitting in my driveway area because I didn't know what to do with it. If you're interested.
Where'd you say you found that one?
It's from the creek on the north side of the Wallowas. I can't remember the name of the creek. It's between the Losteen and the Wallowa valleys. There's the other valley, and we took a hike up through there. And there was a lot of rocks that were washed down from the Martin Bridge and the Herwall formations. So it's undoubtedly from one of those.
And Carol is our field trip coordinator, a former president, and our former newsletter editor. And now she's doing a wonderful series that appears on our Facebook and our GSOC webpage with some of her recent trips that she's taken personally. So thank you. Okay, Aaron, did it look like that when you found it or did it get cleaned up?
Actually, it came out pretty clean like that. It was just, it was quartz up against the crystal faces and it just popped right off. So.
All right. And I think you have the next one in the queue. So
can I ask a question about
Please.
that, Aaron? I'm used to, when I see garnet, it's usually kind of got a reddish, kind of deep purple kind of color, but your sample looks black. Is that what it truly looks like? Is there variation in what those look like?
Yeah, I mean, if you look at a very small fracture piece, it's going to be more reddish purple, but it's just dark enough that it looks almost black with these larger crystals.
There's several different things that we call garnet, or several different colors. So there's grossular garnet is a pea green color, kind of like a split pea soup color.
Oh.
And pyro, this might be pyrote or almandine, and which is the dark, the red. The dark red. The other thing I wanted to say about garnet is, unlike other things that quartz looking stuff had to have a little hole or a space for crystals to form, garnet doesn't do that. Garnet is one of those things that can grow a euhedral or a whelk-faced crystal under compression. It doesn't need a space to grow. That's one thing unusual about garnet. It's able to shoulder everything else out of the way to form a well-formed crystal.
And that's one of the things I've learned in our downtown tour, looking at some of those billion-year-old gneisses on the walls of the building down there. And then they've got these pretty red garnets that are just pop out that are about 1/4 inch across. Should we go to the next one? And I think that's, Aaron, this is one of yours too. So you're quite a collector. That's a beautiful, I'm going to make it a little bigger. And you want to tell us the story there.
Yeah, that one was actually a recent find. Actually, when I was looking at that area, I was going into Dogami. Old Clark still worked there and kind of picking his brain. But this one I just read about in a unpublished Dogami paper. There are some calcite prospects out by the Oahe Reservoir in the Dry Creek area that were prospected during the 40s for optical calcite for bomb sites and for microscopes. But they didn't find a lot of clear calcite. But one of the reports that I read said that one of these calcite veins was something like 25 feet thick and ½ mile long. So I was just curious if they're visible on satellite imagery, and they are. So I did some research and found something like 25 or 30 calcite veins just by using satellite imagery.
The calcite veins are, oh, I would love to see that. That they're visible on like Google Earth, that sort of thing. Wow.
And that's how I found them. And I used All Trails to make a map, which I downloaded onto my phone, which of course the GPS works offline. So I just navigated right to all of them to check them out, covered a lot of ground in a short period of time.
We should talk more about that, because that's a really powerful feature, to be able to get a geological map onto your phone so that you can be out there in the field and really be locating exactly where you're headed. That's great. So sorry, I interrupted you. Go ahead.
Well, I was gonna say, plus you can download the satellite imagery so you can see the color of the rock and everything, and just makes navigating so easy. But this was an area that I came across in Dry Creek where there are just multiple veins along a hillside exposed that had never been touched by anyone. And I was kind of blown away that the stuff was just sitting there where I could just pull it out.
So what's the story of calcite? How to get there? This, again, calcite it's got to come from a tropical sea at some point. Am I right? I mean, originally.
All of these veins are all hosted in the Deer Creek Formation out there, which is kind of orangish, tufaceous sediments. There's some metamorphic clasts in there, which they think they probably come from Idaho. It looked like a large lake deposit. There's some freshwater gastropods in there in some places. But I think the theory is that somewhere not too far below, there's some limestone, which when fluids came up through these faults and fractures, it dissolves in the limestone and then redeposited them in the Deer Creek Formation.
And these veins, is there anything, I'm still an amateur when it comes to crystals, just looking at those crystals, can you tell me that it's calcite from the shape or the I guess the color is pretty distinctive, but I don't know, it could be quartz, I'm not sure.
Don't go by color. Never
don't go by color. Never go by color, except when you go by color, but no. But don't rely on
these
it.
ones, it's pretty easy.
A knife to it. Can you scratch it with a knife?
Let's see. Oh yeah. And you can see the cleavage in the broken pieces. It's got the typical rhombohedral cleavage.
Yeah, calcite's only a hardness of 3, so a steel knife blade will scratch it.
Okay, and if it's quartz, you can't do that.
If it's quartz, it's a hardness of 7, and a steel knife blade will not scratch it.
And the shape of those crystals is what?
See, actually, most of those are rhombohedral, and some of them are twinned.
Okay.
So they look a little more rounded than they might normally.
So I could Google rhombohedral and see what that.
Tell us what you mean by twinned.
Yeah, that's interesting.
Okay. Twinning usually means you have 2 crystals kind of growing together that are at different orientations, but they're following some of the crystallographic axes. And there are a bunch of different twinning laws, which I'm not familiar with all of them. These ones I think are penetration twins.
So is that one
so
that
they can grow through each other. Is that?
Yep.
Yeah.
So that big one on the top looks like maybe it's twinning. Am I seeing that correctly?
I believe so. I'd have to go pull it out of the case and take a closer look. But.
Sorry, I'm on. Yeah, I think we have time for one more. Go back here for a second. And let's see. Do we have anyone else in the panel who hasn't had a show and tell yet that has one here? Oh, we've got.
Wow.
So these are all Aaron's. Aaron, I feel like we could spend a whole hour on your collection, and maybe we should do that.
The gold specimen is not in my collection.
Okay.
However, you were.
Are Gordon and Eleanor here? No? All right. There's another Gordon and Eleanor. And here's one from Clark. So let's hear from Clark. We haven't heard from him in a while. Let's, Clark, what do we?
I thought I just, in my former life at Degami, I had a project I worked with, I got a grant from the Oregon Department of Transportation. And I went out and looked at all their sites and sort of, told them whether there was hazardous materials or in it or not, naturally occurring hazardous materials. And this material here is hazardous. Its hazard is particulate, so its physical characteristics makes it a hazard. This particular photograph is a shear zone, and what you see here is sheared serpentine, so it's a serpentinite. And this particular sample shows you a few things. It shows you a fabric. It shows you an S&C fabric because it's metamorphosed, so it's metamorphic. And an S&C fabric, it means that there's a foliation that goes through it. So these minerals are, if you will, kind of lined up in a line or on layers. And when they shear together, they form these fabrics, an S or a curvy S fabric. And you can start to see some of those kind of curved surfaces down in the bottom of the photograph at the bottom of the pencil.
Is that, I'm
So
moving the cursor. Am I?
Yep. So those are the foliations, and then they have an S, kind of an S surface or an S shape to them. The C fabric we can't see here, and we generally don't see that at all. But you can see there's several different directions. There's even one horizontally across this. I had this analyzed both optically. That's the way you can tell if there's any kind of asbestos forming minerals in this one. And serpentinite is an amphibole in this case, and asbestos is an amphibole a mineral. This one contains chrysotile, and it contains over 1%.
Is chrysotile the bad asbestos?
Chrysotile is the, yes, if you will, if you're going to rank them as good, bad to
the one that's harmful.
Least bad.
Yeah,
There's
least bad. Okay.
And they have to have a fibrous habit or a specifiform type habit. I mean, they're fibers, and the fibers have to have a certain ratio to be classified as a specifiform. So, these are greasy to the feel, to the touch. So, and the green color is characteristic. So on the next one.
Okay.
The next one is in the core. So this was in Chancellor's Quarry. I should say both of these four photographs are from Chancellor's Quarry. That's down there near Grants Pass, just off the highway. As you come out of the pass, the Grants come out of that's not Stagecoach Pass. It's the next one, Sexton Pass. You'll start to get into this this area that contains the rock, which here is a peridotite, and it leaves a nice characteristic brown soil like that. So this is peridotite rock. This was quarried by the ODOT, and it is the largest quarry in Southwest Oregon. So they put this stuff under a lot of the road work down there. And like I said before, it is probably hazardous material if you want to classify that.
So they were using serpentinite as road gravel for
as road base, yeah. So this particular material is enthophyllite, and it is it has a laminar form, which you'd see the crystals are kind of stacked on each other. So that's where lamina comes in. It is also fibrous, and optically and chemically, and we used a TEM technique, a microscope. It's like a microscope, an electron microscope, and I know that there's fibers in this one, and this one also is kind of gets up to the point where it's a concern. but this peridotite is full of this enthophyllite, and I think it just was a pretty neat, these pods and veins and this stuff in here. So that's my show and tell.
Those are beautiful.
Peridotite forms deep in the mantle. So
Right.
it's
It's an
not
ultramafic rock.
Tell us the story of how serpentinite ends up in Grants Pass.
Well, this is part of the terrains, part of the Klamath terrain. And this particular rock, or if you find serpentinites, and particularly in shear zones, means that we are pulling these rocks from deep within the mantle from the Earth's surface. So I think we're in the Western Klamath terrain there, subterranean. And if you ever want to map in there and have an awfully good time and really, you're overwhelmed at one time and puzzled at the other and can never figure it out, here you go.
Yeah,
This is
we had a great field trip down there a few years ago. And if you were at the meetup, 2 months ago, Brooke Thompson brought in that beautiful serpentinite. It was it wasn't in situ here. It was a cobble, but from her tribal homeland down there in the Klamath River. So similar origin of one of these great accreted terrains that crashed into Oregon. And then Sheila, maybe take it from there. Explain how you get serpentinite in these accreted terrains, if you can.
Okay, well, first of all, if they don't know what accreted terrains are,
explain that.
I need to tell you about that because that's so wild. You think I'm making it up? Okay, so these two regions of Oregon, the southwestern Oregon and northeastern Oregon, are both made of land that started somewhere else, moved across the Pacific Ocean, and got glued onto the North American continent. Okay, so in the process of doing that, we had places that opened up, ocean and deep rock from deep below came to the surface, this peridotite, and then it gets metamorphosed, squeezed, because these land masses attached onto North America. In that process, it squeezed them, and that turns it into serpentinite.
Okay.
That's the short version. Okay.
All right.
That's so wild. When I used to give tours down at the Oregon Caves, and while I worked down there for the summer, and I gave lectures to the workers there. But basically, that is so wild to think about. Here the Oregon caves are marble and most caves are made out of limestone. Again, the story and the fantastic part of the story is that it's accreted terrain. That if you believe me when I say that these land masses moved across the Pacific Ocean and got slammed onto North America, that's pretty wild stuff.
It is. That's one of the best stories of Oregon. And I guess the Wallowas,
you'd think I'm making this up,
We believe you.
Yeah. Okay.
And the limestone that we were talking about in the other corner of the state, the northeast corner of the state, is a similar accreted terrain, something that, a Japan-sized island. And earlier, Andrew was talking about Rangelia, which
same thing.
That's also one of those accreted terrains. So that's a big part. If you're interested in that, Nick Zentner is doing a wonderful job with that whole topic on both his podcast and his videos, and he's actually getting out into some of those accreted terrains. For those of us who are stuck at home, it's kind of nice to watch Nick wander around and find serpentinites. We're almost at our hour. I think, Aaron, I hope you come back because you've got some fantastic stuff there and fantastic stories to tell. We'll be back next month with again with Andrew in the geology news, and I hope the rest of you come back. If you are a member, October 9th again for Dr. Stragg's wonderful lecture on the Gales Creek Fault and the methods to discover that. But if you're not a member, come to the website the next day, and you can watch the lecture there from YouTube. I think that's it. We got one more minute. Anyone else got anything else they want to say? Well, I'm not going to kick everyone out this time. I'm going to walk away from the screen. If you want to stay and chat amongst yourselves, I don't have anything else on this channel, and I have a meeting at 2. We'll have to kick people out. But I'm going to have Carol stop. I'm going to thank everyone first. Thank you, Sheila and Andrew and Patty and Clark and Scott, if he's still here, and everyone else who helps, Aaron, other people who want to contribute to show and tell. You're all part of what makes this work for us in a time where we can't be in person, but we will be once again at some point. So we'll see you in a month, or we'll see you in a couple of weeks. And thanks for coming. And Carol, you can shut off the recording.